A very good morning to my dear computer students. Let us start our today's lecture. We were discussing chapter 9, data structures, stacks, queues using lists. So beta, in this chapter we have already discussed the introduction part about the data structures and the operations that we have discussed that part in detail also. Now we'll be discussing the main part of your chapter, that is stacks. So what is stack? Stack is a linear structure that is implemented with the LIFO. What is LIFO? LIFO means last in first out. This is the principle of stack. This we have discussed in last lecture also. Let us discuss this point or this principle in more detail now. So we have taken an example of a bag in which we are putting the clothes. So which cloth will be able to take out first? That is at the very top, means that we have placed at the very last. Okay, so same principle is being implemented here in the stack also. Initially our stack is empty. See, there are two main operations that we must know that we can implement in our stack data structure. Okay, and one pointer. Okay, two operations and one pointer, and the pointer is known as stack top. Okay, top is a pointer. Why I'm saying pointer? Because it keeps on pointing the current position in the stack. Like my stack is having nothing, the top is pointing to none. Okay, so when we have inserted one element into the stack, then top is pointing to the first element. When we have inserted another element, then top is pointing out to the second element. So if we will insert another element, the top will point to the topmost element. So always top points to the topmost element of the stack, whether it could be this one or it could be element that is above it, right? So wherever the last element lies, the top will be pointing to that. So that is why I'm taking the name of top as pointer. Okay, so this is a pointer, top is a pointer which is pointing to the topmost position of your stack. Okay, so if we'll add one more element to stack, the top will be incremented by 1, and if we'll delete one element from the stack, then the top will be decremented by 1. Okay, I hope it is clear to you. So if we are adding, then top is incremented by 1, and if we are deleting, top is decremented by 1. Okay, so now let us take a look at these two operations that we can perform in stack data structure. One is your pop operation, another one is your push operation. Okay, in just this example only I have discussed this. When we are adding one element to a stack, that is known as your push operation, and when we are deleting one element from the stack, that is known as pop operation. Okay, data can be removed from the top. Okay, see, we can add on just on the top of the stack, and we can delete from the top of stack. Okay, so whatever is at the top will be removed first. Okay, and if you are trying to remove from this particular type of stack that does not hold anything inside it, then this type of condition will be known as underflow. This will be discussing in detail further. And if we are trying to add more and more elements and the size of this stack doesn't support addition of any element, in that case we will be calling this situation or condition as overflow. Okay, so let us know more about these operations. Pop operation, I think, is clear to you. Removal of an element from the stack is technically known as pop operation. Similarly, when we are adding a data element at the top of the stack, okay, see this keyword top of the stack should be mentioned, because if you are not mentioning this top of the stack keywords, these keywords, if you are missing out, then your definition of pop and push operations are incomplete. So you should make it sure that whenever you are defining this push and pop operations, you must write deletion from the top of the stack and insertion at the top of the stack. Okay, then only the definition of insertion, means pop and push operation, are complete. Fine. So now let us see what he is trying to do in this particular diagram. Initially the stack was empty. Okay, so top is pointing to none. means nothing is there, the top is pointing to none. So once we have pushed to 32, element 32 in the stack, now top will not point to null, it will point to this 32, and every position, every place in the stack is holding an index for its reference, so its index would be 0. Okay, or we are always starting the index of the stack from 0. Fine. Next element if we are inserting, so it will be at index 1. Similarly, it is 0 and it is 1. Okay, so we can say top was initially pointing to 0th index. Now it is pointing to index number 1. Okay, now what we are doing? Again we are, see here we have pushed, matlab we have added an element 32. So it was, top was pointing to index 0, and now again we have added one more element to this stack. Now the top is pointing to index 1. Fine. And now what we are trying to do in this particular diagram, we are popping one element, means we are removing one element, and that one element is 18. Okay, when we will take it out from the stack, okay, then what will happen, the top will again point to 32, that is at the index number 0. Okay, now what we are trying to do, we are adding 29. So if we are adding 29, again top will be incremented by 1 and it will be pointing to this, again the index will be here, it will be 0, it will be 1. So top is pointing to index number 1. Okay, now what you are trying to do, you are removing 29 again, and if you will try popping one element again, then top will again point to none. Okay, I hope it is clear to you. So push and pop, two operations we can implement on a stack data structure. Only two operations, either pushing or popping. Okay, now stack is a dynamic data structure as it can grow, okay, or shrink, means we can add elements and we can delete elements. Okay, so the size of the stack will keep on changing according to the addition and the deletion, means according to the push and pop operations being performed. Fine. Now a static data structure on other hand has fixed size, it cannot shrink or it cannot grow. So we can say stack is a dynamic data structure. Okay, stack is a dynamic data structure. Why dynamic? Because it can grow or it can shrink depending upon the push and pop operations that we are implementing on that stack. What is the principle of stack? It is LIFO. LIFO stands for last in first out, means whatever element is added up into the stack at the last will come out first. Okay, and all the insertions and deletions are take place at the stack's top. Okay, I hope the concept is clear. Now some terms that are related to the stacks, upon which the questions are asked many times in your exam, so you must listen to these concepts very clearly and try to recall them in your mind again and again, so that we may use these concepts in our program also. Okay, now what is peak? Peak refers to inspecting the value at the stack's top, means whatever value is present at the stack's top. Stack's top, whatever value is present without removing it. So whatever we are just looking at the stack and we are trying to know what is the topmost element present on the stack is known as inspection. Okay, just like your teacher is doing inspection of your notebook, that what work you have done till date. Similarly, we are checking whatever which element is present at the stack top. Okay, we are not performing any operation in peak, we are just inspecting it. Okay, now second is overflow. Overflow, actually it is a situation, or we can say it's an error. Why we are saying error? Because there is a finite length of the stack, means we can add only a finite number of elements to this stack because it is holding a size, and when this size becomes full, okay, and then we try implementing the more elements to this stack, so then where it could be inserted. So like I'm inserting elements again, I'm inserting elements. Now I try to insert element where I could be able to insert then my new element. So if I'm trying to insert a new element which cannot be inserted, actually why? Because the size of the stack is no more supporting it. In that case we will find an error, and that is known as overflow. Okay, So actually stack will not notify you that the size of the stack is now full. So we have to put a condition in our program to check it whether the size of maximum size of the stack has been reached or not. Okay, so because further that we cannot grow further and no memory is left to accommodate to be accommodated by the new element. Okay, next is underflow, means there is nothing inside the stack and you're trying to remove one element. How it could be? See, if one element is there and I'm trying to remove it, then definitely it will get removed. But if there is nothing inside the stack and still I'm trying to delete something, I'm giving a command to delete one element from it, how it could be possible? So in such situations where the stack is already empty and we are trying to remove one element out of it, that situation is known as underflow. Again, it is an error, so the means the program itself will not notify us. So what we need to do, we need to put a condition to check whether the element is present inside the stack or not, whether the stack is empty. So we just need to confirm it by putting a condition in our program. So in order to avoid these two boundary cases. Okay, why I'm saying boundary cases? Because overflow will occur when we are at the topmost boundary of the stack where we do not have any more space to insert. And why I'm saying the underflow as a boundary condition? Why? Because we are at the boundary of the stack and we don't have any element to pop out, right? I hope the concept of underflow and overflow and peak is also clear. Fine, now let us take an example. So beta, you have been given an example and it is clearly mentioned that capacity or the length we can say of the stack is 4 elements only, means it can hold 4 elements. So how it will hold 4 elements? The index will start from 0, 1, 2 and 3. So it will hold 4 elements. So if you are trying to insert more than 4 elements, then obviously overflow will occur. And if you are trying deleting an element, which is means if there is no element inside the stack and even then you are trying to delete one element out of it, then underflow will occur. So both the situations we must try to avoid by putting a condition in the program. Okay, so initial state of the stack is this. Now we need to see, first condition is stack is empty. So this is shown properly, top is pointing to none. Okay, now we are pushing A. In second case, what we are trying to do, we are pushing A, means an element we are pushing. So when we have put one element inside it, then now top will point to index number 0. Okay, top is 0. Fine. Always keep a check on the top position, because without this neither the insertion nor the deletion will be successful if top is not incremented or decremented. Okay. Next is third part, pushing B, means again we are adding one element. So A has taken the index 0, now B will be at index 1. Fine. So next you can see push C, then pop. Pop may you are not supposed to tell the element name, because pop can only occur at the topmost position. Top wali position pe hi pop hoga, and whatever element is at the top, that will be taken out. And still, if you want to pop out one another element, another pop, you can give pops like that. Okay, because we cannot directly remove an element from the stack. So next was to add B, then to add C, and then to pop one first element. So which will be the first element? After adding B, the top is now 1. Now what we want to do, C, again we have added C, push C. In fourth step we have added 4C. Here we have added C in fourth, right? Fifth step says take out the last element. So C has been added at the last, so it will be taken out first. So we are just taking out C, and then the top will be decremented by 1. Earlier it was 2, now it has become 1. Okay, now what sixth step says? Push D. Now again we need to push D, means we have to add D. So where it could be added? At the top position. So top was here, and now when D is added, top will be again incremented by 1. Now 1, 2, it will get converted to second position. Now again you see what next step is saying, pop. So what was at the top? D it was na. So when we will take out D, fine, and the top will again decremented by 1. Now top is pointing to 1. Okay, now again push E. Okay, so where E will be inserted here and top will again be incremented by 1. So we are inserting E here at the second index and top is now pointing to 2. Okay, now third is means ninth is push F. So now we'll be again adding one more element to it, F. Okay, now you can see top has been incremented by 1. Now it is top is 3. Okay, next is push. What push it? He has not told anything. Why? Because there is no space left. Still we want to push something. That is just not possible. Why? Because overflow has occurred. Why? We have reached the boundary condition and we are still trying to insert one element. So that will not happen at all. Okay, that is overflow. Still, if you are trying to add anything, that will not be possible. Now you are trying to pop. So pop, how it will change the structure of your stack data structure. So F will be removed and the pointer will be decremented to 2. Okay, next you can see in 12th what is trying to say, again pop. So again pop, see how many times pop we have to do, 1 2 3 4 more pops we need to do. So see, 1 pop, 2 pop, 3 pop, and next time when you are trying to do pop, then underflow. Okay, because when A has been removed, nothing is left inside your stack data structure. Still we are trying to perform one more pop, then top is all, it was already none, and still we are giving a command to remove it. So ultimately it will give underflow. Okay, so this was all about today's lecture. Thank you so much, beta. Keep on revising this concept so that this concept may be fixed up in your mind. Thank you so much.